Hello, this is Ruban. I am a sales and application engineer at Divine Technologies. So today I'll be demonstrating the 6 series MSO. So you can see this is the instrument which is along with us, which is having a capacitive touch screen display over here. So this is available in various models like 4, 6 and 8 channels. Then it has a bandwidth which is ranging from 1 GHz to 10 GHz. So it is completely upgradable. So if you have procured a 1 GHz bandwidth oscilloscope today, and in case in future if you want to upgrade the bandwidth up to 10 GHz, you can upgrade that by just purchasing the software. Okay. So today I'll be demonstrating the 6 series MSO along with all its feature and other things. So for demonstrating this, we have this oscilloscope, we have some probes along with us, and we have this this is called as a demo board. So we will be generating some signals with the help of this demo board, and we'll be seeing them on this scope. Okay, just to brief about the scope, so this is a 6 series MSO. The current model is of 10 GHz bandwidth, so it is available from 1 GHz to 10 GHz bandwidth range, and which is completely upgradable. Okay, so if you have procured a 1 GHz oscilloscope bandwidth today, and if you want to upgrade the same oscilloscope in future, you can upgrade it up to 10 GHz. So in order to upgrade it, we just require some licenses, and like it is a post purchase thing. Okay, so coming to this 6 series oscilloscope, so it has a sampling rate of 50 gigasamples per second, so which is for channel 1, and if you use 2 channels, the sample rate get divided into 2. So on 2 channels you will get 25 gigasamples per second, and if you start using more than 2 channels, then the sample rate goes up to 12.5 gigasamples per second on each channel. So this is how the sampling rate get defined as per the increment in channels. Other than this, when you see this channel, so this is like having this smart interface. So this is called as flex channel input. So in this you can see over here it is having some circuitry inside as well. So what is this circuitry used for? So this one single channel, it can be used as an analog channel, and simultaneously along with the analog channel it can be used as a spectrum analyzer as well. So that will be demonstrating in the next few steps. Okay, other than that, if you want to convert this same analog channel into digital channel, you can use this logic probe. Okay, so as soon as I connect this logic probe, you can see over here this single analog channel is converted to 8 digital channels. Okay, so simultaneously you can connect up to 8 analog channels. So 8 into 8, it is 64. So that many number of channels you can utilize in this simultaneously. Okay, so this is how the basic thing, like one channel can be used for various purposes. Other than this, it has inbuilt arbitrary function generator. Then it has some other features as well, like it is available in Windows and non-Windows options. Then other than that, we can do various decoding in this oscilloscope, like I2C, SPI, CAN, DIN, and there are n number of modules which are present, which we can decode with the help of this oscilloscope. But these are the optional modules. If you want, you can procure it. If you don't want, you can just ignore that. Okay, other than that, it has some compliances as well, like if you have procured the Windows option and you want to do some compliances like USB 2.0, Tech Express, then Ethernet, then automotive Ethernet, all those things are possible. And so this is the basic introduction of the instrument. So coming to the operations part. Okay, so previously, like you might have used some oscilloscope which were having like basic decoding techniques and all those things, but this one is having a better GUI. I think the best GUI which is there. So coming over here, you can see as soon as I connect any of the channel, so there are 3 to 4 ways in which I can operate this channel. Okay, first is I can just use my fingers, and you can see over here by using my fingers I am just setting the channel levels over here. So you can see, so this is how by using my fingers I have just set the channel levels over here, like volts per division, times per division. I can just pan, zoom the things, and I can just see the channels over here. Okay, coming to the same part, you can use it in this fashion as well. Like you can use this button. So So this is like position and scale for the voltage part. Okay, volts per division, what we call in the basic language. So that we can do with the help of this volts per division scale. Okay, other than that, we have this position button. You can change the position from this part. You can change the position from this part over here. You can just drag it and the position will get changed. Okay, so these are the two ways. Now if I want to have one more option, I'll just use this button over here, channel 1 setup, and from here I can change the scale as well. This is the third option. If I want to have some accurate settings in over here, I can just set it to 1.2 volts per division. So that is also possible. As you can see, we have given various interfaces for one single operation. Like suppose this has stopped working, we can use our touch. If touch is not working, we can use the mouse, and other than that I can change it from here as well. You can see this small logo over here. With that also we can just change the volts per division scale. Now like you are getting some signal on the screen. So currently it is not being triggered because the trigger is set to channel 2. Now I have set it to channel 1. Now it is getting completely triggered and the waveform is stabilized. What happens is when you are using any traditional oscilloscope, so in those scopes, whenever you connect any of the signal, so at that time what happens is there is a small glitch or a compensation part you may call. So the signal is slightly undercompensated or overcompensated. So for that we require a screw and we need to do the adjustment on all those things. But this is a smart probe. So that's the reason we have given some more features over here. With one single click, I can just compensate this signal. I'll just double click on channel 1. I'll go to probe setup. Here I'll just click on compensate probe and I'll compensate it. That's it. And now it is showing the status as the compensation is running. Once it is shown as passed, you can see over here all the glitches have been removed from this part. Okay, so this is how the compensation takes part in this oscilloscope. Coming to next part, we have this other functions as well, like the position which we have shifted from here. We can access the same from here as well. You can see I can rotate this knob as well. I can set it to 0 from here. If I want to add some DC offset, that also can be done from here. And coupling, whether I want to set it to AC or DC, that also can be done from here. If I want to limit a bandwidth, suppose I'm working on a low bandwidth signal, okay, and it happens like this one is having a high bandwidth of range, like 10 gigahertz is very high. Okay, so if the oscilloscope is having that much high bandwidth, what happens is high frequency noises, they also get interfaced in the signal. Okay, in order to avoid that, we have this bandwidth limit functions. So it will limit the bandwidth to that specific frequency only. Like we have options as 20 megahertz, 200, 250, 350, 1 gigahertz. So depending on your requirement, suppose you are using a 1 megahertz signal, this is the 1 kilohertz signal. You can see there is a lot of noise in the signal. Okay, as soon as I limit the bandwidth to 20 megahertz, I see the signal is very sharp, right? Because all the noises have been removed in this, which are greater than 20 megahertz. Okay, so this is one of the feature, like you can just limit the bandwidth and eliminate the noises. Okay, coming to next part. Okay, so this is one of my basic application. I want to view the time domain and frequency domain simultaneously. So what I can do in this case is I'll just use the spectrum view. So as I said in the beginning, like this channel, it is having like it is a 3-in-1. You can use it as a analog channel, you can use it as a digital channel, or you can use it as analog as well as spectrum view channel. Okay, so this is where the spectrum view comes in picture. Okay, so here I just switched on the spectrum part of this specific waveform. You can see it over here. Okay, so now I'm just placing it side by side. I'm not getting any specific actual data over here, right? So for that, for spectrum, we need to do some settings, right? So this is a 1 kilohertz signal. So basically the center frequency for this, it should also be 1 kilohertz, right? So we'll just go to the settings, spectrum settings over here. We'll set the center frequency as 1 kilohertz, okay? and this is the span of the signal. We can set it in megahertz. Just let's see if what happens if we set it in 1 mega. Okay, so it is showing some noises. So here you can see this is my 1 kilohertz signal, and these are the sidebands which are present over here. I can just increase or decrease it like 10 kilohertz, 5 kilohertz, and so on. Okay, so this is how the things work simultaneously. This is the patented technology by Tektronix, where you can view the time domain and the frequency domain simultaneously. Okay, coming to other part, like this is one of the thing. Now if I want to do some mathematical operation, so that is very challenging, as we have like basic oscilloscopes. In basic oscilloscope we do have addition, subtraction, multiplication, and maximum it is division, but this one it has some advanced mathematical operations as well. I'll just add math operation over here. So you can see the basic one is having addition, subtraction, multiplication, division, right? These 4 options are there. Then we have some filters, like if I want to create any filter, we can just implement it over here. Then if I want to view the fast Fourier transform of the signal, that is also possible. Then we have this advanced function. What is there in the advanced function? So we can do integration, we can multiply by sine, we can take the sine, we can take the cos, we can do n number of operations which are there here, right? So you can just create your own equation and you can just implement that in this. Okay, so let's take an example. I don't know how the integration of a square wave looks. Okay, so I'll just do one thing. I'll take integration of channel 1. Channel 1 is a square waveform. I'll just complete the bracket and click OK. So as you can see over here, I'll just close the spectrum part. Yeah, so you can see at this part, right? So this is how this is how a integration of a square wave looks. Similarly, you can perform various operations by going in the advanced math equation editor function. You can add, multiply, subtract, divide, do integration, do differentiation, and many more options available. So this is like proper implementation of like arithmetic operation of a waveform. Okay, so coming to the next part, suppose I want to add some references, that also I can do by just recalling this reference waveforms. Okay, then we have this internal digital voltmeter as well. So you can just click on this, the DVM gets activated. What are the functions which you want to perform? So DC voltage, AC RMS, DC plus AC. So all 3 functions are there. You can just see the statistics as well. So these are the 3 functions which you can perform with the help of this. Let's take an example. So this is the board which we have. Okay, so the oscilloscope which we are using over here, it is having a waveform capture rate of up to 5 lakh waveforms per second. And for this we have a patented technology which is called as fast acquisition technology. Okay, so I'll just turn off the channel, second channel. I'll remove the signal from the compensation part. Can you just help me remove that signal? Okay, so in this board we have few signals like fast occurring signal and rarely occurring signal. Okay, so okay, so this is the fast anomaly. Okay, I'll just connect it with the ground over here. So this is the signal which is coming continuously. Okay, now you can see some of the signal is just coming and going over here, but I am not able to even capture that signal or even view that signal properly, right? I'll just use one thing. I'll just go to acquisition. I'll use the high resolution. Yeah. So this is the fast acquisition technology which is used in horizontal. Okay, I'll just activate it. You can see over here the signals which were in red, they were continuously occurring signal, and the signals which is over here, you can see it at this point. So these are the rarely occurring signals which are there. Okay, so you can view them simultaneously. So this is the continuous occurring signal and this is the rarely occurring signal. Okay, so I'll just try to zoom it a bit.
Remove the trigger.
Sorry?
Remove the trigger. There will be a runt.
No, so okay, so this is the fast like rarely occurring signals. Okay, so now we'll just shift to some frequently occurring signal over here. So in this you can see over here there are some runt pulses present over here. You can see in blue color, right? You can just zoom into this and you can show that as well. So these are the signals which are coming and going, but we are not aware of them whether they are coming in or not. So if I turn off the fast acquisition technology, you can see this is what I am getting. I am not even able to get whether it is the runt is present or not, right? So in order to capture that runt, we have this technology in which we can trigger on a runt pulse only. Okay, so my source is channel 1, I am triggering on a runt pulse. I'll select the two types of threshold level which are there. So upper threshold level we are setting it to 2.4 and the lower threshold level we are setting it to around, which means it should be in such a way that the signal's peak should be between those two pulses. Okay, so this is what I am getting. So I can change the polarity like either positive, negative. So these are the things which I can do over here. Next is, suppose I want to save this data, like as soon as I get any runt pulse, the data should be stored. So that also I can do with the act on trigger function over here. I just need to activate this act on trigger. I'll just tick mark what are the functions which I need to perform. Whatever I take it over here, those things will be activated, like saving the waveform, saving the image, saving the setup, saving the complete session files. So these things will be performed with the help of this. Okay, coming back to this part. Okay, so now we want to do some analysis part. Like this is one of the runs which I am getting over here. I take some more time of data. Okay, I have lots of data in my screen. I don't know how many runs are present over here, what are the things over here. I just increase some record length. Okay, so this is some big data is there. Okay, I'll just stop the signal. Now I want to find how many runt pulses are present. Okay, I'll just go to search. Okay, I'll copy all the settings which are there on trigger. So here you can see this option, copy trigger settings to search. I'll just copy that settings, and wherever the runts are present, I'll be able to find that. Okay, so you can see the setup over here. Setup is called as runt, channel 1, when runt occurs. Now I'll just zoom into a part of this. Okay, so you can see over here we are having a runt pulse. Okay, and similarly if I just select on next pulses, wherever the runt is present, it will show that. Okay, so this is how like you will capture the runt pulses. Okay, and just zoom out of this. So you can just see over here, like after just clicking on either left, right, and I can just have that runt pulses. This is one runt, this is second, and I can just go back to the first runt as well. Okay, so this is how the things occur in this 6 series MSO. Okay, coming to another part, like we have a bus decoding protocol also present in this. So we will try to decode one of the SPI or I2C clock pulse, the data, and we can just see the results on the screen as well. Okay, so in order to do that, we have this add new bus option. So in this you can see it is very simple operation, very simple. You just need to select which type of bus you are decoding. So suppose we are decoding I2C bus. So you just need to define like what is channel 1 and what is channel 2, what is clock and what is data. Clock is also. So now I have a challenge, like I want to decode one of the RS232 signal which is just present on this board over here. Okay, so I'll just guide you how you can use this. Okay, so first of all, like we'll try to get the complete signal on the display. Okay, so we just adjust the volts per division scale, the times per division scale, and we'll try to get the exact signal on the screen. Okay, so this is what the signal is. Okay, now I want to utilize the signal to get the data. Okay, so and after getting the data I want to decode that as well. Okay, so for that I just use this decode over here, in which I'll be using one of the inbuilt decode function which is called as RS232. Okay, so as soon as I click on that, you can just see that we are getting some packets over here. So this is just the decoded format of the signal which is just above that. Okay, so you can just select the data bits as 7-bit, 8-bit, 9-bit, whatever is your data rate. Then you can set the threshold value, at what threshold you want to capture. Then you want to have inverted function, normal function. You can select the source. You want to have even parity, odd parity, or you don't want any parity. If you want to have a packet view, that also you can define from your end of packet. You can just define. So these are the basic settings which are there, which you can use. And other than that, you want to have the bus as well as data. You want to decode in binary, hexadecimal, or ASCII. So whatever is required, you can just select it from this, and you can just decode that pattern as well. Suppose I have a long series of data over here. You can see like I have too much of data. I just stop the signal and I try to just zoom into it. So this is what my zoom function is. Okay, so I have currently zoomed into this one, and you can see like I am getting something over here, and that data is also being decoded. Okay. So this is what the data is, and if I click on this result table, I can just add this bus decode as a result table. And you can see the complete data in this decode as well. Okay, on whatever data you want to go, you can just double click and it will just take you to that data itself. Okay, and if you use any other settings as well, like zero, null, even parity, odd parity, you can just select it from here and you will be getting that data. Okay, so this is that simple. After getting this data, you can just save this table by clicking save as. So this will be saved in a CSV format, and you can extract it to your PC or any other thing, and you can just view the same as an Excel. Okay, then coming to next part. Okay, so this is one of the basic thing. Now let's just go back to the basic settings. Like I'll just go to default setup and I'll click auto set. So this is what when we come to when we set it automatically. So this is the measure function. In this you can see we have amplitude measurements, which is having like amplitude, then we have maximum, minimum, everything related to amplitude. These are the automated measurements. In 6 series we can add infinite measurements. You can add n number of measurements. Like some oscilloscope, they have a limitation of around 8 measurements, 10 measurements, 16 measurements, but this one you can add n number of measurements. I'll just show you by adding amplitude, minimum, maximum, peak to peak. Then I'm adding n number of readings over here. Then other than that, I want to do some timing measurements as well. So I'll just click on measure and just go to time. So I'll measure period, frequency, then rise time, fall time, everything. You can just see how many readings are being added in this column over here. So I have taken so many readings. Now I want to view them. Like where are these readings? I can't view them simultaneously, right? So I'll just go to result table and click on measurements. So here you will find this data. this is what I am having measurements currently. So amplitude is there, minimum is there, maximum is there, what is the mean value, what is the minimum value, what is the maximum value, everything will be plotted over here. Okay, other than that, if I want to take some special readings, okay, suppose this is my amplitude, I want to view the histogram of that. I will double click on histogram, the histogram will automatically get added. This is how you can see, like I have added n number of plots, readings and many more things, and you can see over here all the things are displayed on the screen without even a single microsecond of delay. You can see I can adjust it anywhere where I want to shift, I can shift it, I can do whatever operations I want. So this is like having complete like user interface, like user is free to do whatever he wants in this case. I can save this complete screenshot. Now I'll just show you one example in which I'll be saving this complete thing as a report. Okay, so for that I'll just go to file, I'll click on save as, I'll click on report, complete report. Okay, so I'll just click on save. So this is the complete report has been saved to our whatever location which we have specified. I'll just go to this folder. Here you can see Tech00, this is the report which is there. So in this you can see which model we are using, what is the serial number, what is the version, then what is the probe type, probe model, probe serial number. All these things will be recorded over here. Like you can see channel 1 we have TPP 1000, channel 2 we have TPP 1000. Then what are the measurements we have taken? So total 19 measurements we have taken. First one is amplitude, maximum, minimum, on which channel we have taken, what is the maximum value, what is the minimum value, what is the mean value, peak to peak. Then the plots for each of them, like spectrum, view, time domain plot, then histogram plot, then what was the gating setting, that also is being taken by this. You can see over here reference level configurations from channel 1 to 8. This is the reference level which is set. So like the complete report you will get it over here, and you can give this report as your submission. You can just submit this report and it will get verified, like we have used this probe, we have taken this measurements, and you have done all these things. Okay, so this is how like you can utilize this oscilloscope. Okay, then other than that, like you can I'll just show you how to use this logic probe as well. So this is TLP 058. You just need to connect this probe. I've just connected it and just set it to default. Okay, so I'll just remove other channels for now as we are taking the demonstration of this probe. So once you connect this probe, you can see the yellow light gets on over here. You just need to lock it by shifting this at this side. This is in open mode. You can just lock it by pressing it over here. So now it is in lock condition. If you want to remove it, you can just rotate it anti-clockwise and it will get removed, or else you can just lock it from here. Okay, so now these are the channels which are there. Here is one of the signals on this board where we will be connecting it. Okay, so we will be connecting from D0 to D7. So we have connected this logic probe and it is connected to this logic channels from D0 to D7. Similarly, you can see on the screen we have connected only one single channel with this 8 logic probes. So we are getting this 8 signals over here. I'll just try to zoom out a bit so that you get a clear view of the signal, what the signal is actually. Okay. So, yes, all the signals here are as one high.
Time scale बढ़ा.
So you can see over here, we can set the threshold of each channel We can turn on or off any of the channels, like channel 1, 2, 3, 4. I just want to keep these 3 channels. I can activate it. I want to decode these channels. I'll just go to add new bus, and in this I'll just click on parallel bus. Okay, after parallel, clock data any that we need to define. Then I want to have bus in binary or hexadecimal. I want bus plus data. I want to define the inputs. I have channel 1 of D0, channel 1 D1, channel 1 D2. I want to add only these things. So if you see in the binary format, 111 is 7. So it is showing is this is the MSB, this is the LSB, and the data is 7H. Similarly, if you get some other data, so that also you can just decode it up to 64 bits for single unit. So that is how you can decode this like high bits as well. If you want to do some compliance testing, so we have automotive Ethernet, we have D5, we have LVDS, we have DDR Ethernet, then USB 2.0 as well. So the procedure is very simple in this. If you want to do USB 2.0 decode compliance, you just need to initiate that, and in that, like okay, it is initializing. Okay, so for that we need to turn on different software, and few extra things are required. So how to get, like, what are the extra things required? Just click on help. This is the complete help guide. Here you can just type like what are the things required, like USB 2.0 or something. Okay, you can just type it over here, and you will be able to like get that complete thing, the complete what we call as the connection diagram and all those things. Or if you want to have a demonstration of that, you can just click on this utility, go to demo, and here you can see the different measurements or demo files are there. Let's just take an example of DPM measurement. Like I want to do some ripple measurement. So these are the inbuilt files which are there, which we are recalling, which is called as session files. So this is how the data has been taken, and we are getting the output over here. Similarly, we can recall various session files like DDR measurements, DDR R3 burst mode. So it will recall that complete session. So this is one of the feature that we have in our scope. Like you can save this complete setup as a what we call as session. Okay, this complete thing as a session, and if you recall this complete thing in another oscilloscope, so along with the waveform, the readings, everything will be recorded if it is the same 5 series or 6 series MSO. Okay, so you can see over here the complete session has been recalled over here. The readings, the waveform, the channels, everything you can recall it over here. Other than that, like, so these are like the basic things which are there, and you can utilize it. So you just require like basic settings. You can just click on that specific channel or that specific thing, and you can just click on how is the connection diagram for that. If I click on this power measurement and I click on connection details, just a moment, I'm not showing the connection details over here. Okay, so I'll just, so here it gets activated when you have your own oscilloscope. So as this is the demo version, so it is not activated over here. Once you have your own oscilloscope, it gets activated. How are the connection waves? So here are the things. It is also written like what is the thing and what is the procedure. So you can just follow that and you can utilize the complete scope. Other than that, like we have one more feature in our scope, which is called as visual trigger. Okay, so suppose this is my channel. Okay, so this is a default setup which I am just making. Okay, so I'll just click on this auto set. So it is setting the volts per division and times per division automatically. here we have this visual trigger. Okay, so visual trigger is something where you can draw few visuals like few boxes, and you satisfy a condition where A and B both the triggers are present, then only you need to pass the signal. If A and B are not present, so there are various options. Suppose I draw one of the trigger over here, okay, another trigger over here. So to draw that, I just need to click on this. This is one more, and I'm drawing one more at this point. Okay, so I can set the criteria from here. What I want, A and B and A1 and A2 and A3, or A1 or A2 or A3, or whatever criteria. It's like you can set your own logic. If you want all three triggers, you can set the condition accordingly. You want any one of them, you can set the conditions. A or B, A XOR B, those things are already present. You can add more number of this as well. So if it satisfies all these four, you will get this data over here. You can see. So if it is satisfying all four conditions, then only it is triggering and it is showing another data for us. If you can add more if you want. Okay, so this is how we can just use the specific triggers and utilize this 6 series MSO. Hope you've enjoyed my demonstration, and hope I have cleared many more things. If you require any help, you can reach out to me. I have shared my number in the comment box in the description, and hope you are doing well. Thank you for watching. Have a good day.